Hello friends, today in this video we'll try to solve the question from LeetCode, that is the maximum area of a piece of cake after you apply a horizontal and vertical cuts. The difficulty level that is mentioned for this code is medium. Now let's start by understanding the problem statement and the constraints given to you. So the problem statement over here mentions that you have been given a rectangular piece of code which has height and width h and w, and you have two arrays of integer that are horizontal cuts and vertical cuts. Now what these two represents is the horizontal cut array would have n number of integers where each integer represents the cut that you have had on horizontally on the cake from top, and the vertical cuts mentions all the cuts that you have had on your cake from the left side of the cake. Now when you find the area, the maximum area of the largest piece of the cake that you can pick up from the cake, now after having the cuts, you have to return modulo 10 to the power 9 plus 7. Now this is just done to make sure that the answer is in the integer limits, nothing else. So there is no logic behind this, but just to make sure that the answer that comes up is in the integer range. Now let's see the constraints that are given to you. So the constraint that are given to you mentions that the height and width of the cake may vary from 2 to 10 to the power 9 units, and the number of horizontal or vertical cuts can be minimum of height minus 1 or 10 to the power 5, or width minus 1 and 10 to the power 5, whichever is lesser from the two. So this is the main constraint, and of course any vertical height, any particular vertical cut that is there has to be lesser than the height or the width. The vertical and horizontal cut, each element would not cross the simultaneous limits. So that is one thing. Secondly, they have also mentioned that the horizontal and the vertical cuts have distinct elements, so you don't have any repeating elements. But they have not mentioned if the elements are sorted in the from the top to bottom or from left to right. That they have not mentioned, that you have to take care of while calculating the largest piece of cake there. Now let's first understand few examples and figure out what is the best approach that you can take up in this question and solve it. So now let's have this example where your height is 5, width is 4. Your horizontal cuts are mentioned as 4, 1 and 2 unit, and vertical cuts have been mentioned at 3 and 1. So I have drawn the piece of cake which has height of 5 and width of 4, and I have had these red lines mentioning the cuts that have been given by these two arrays. So it can be clearly seen that the largest piece of cake that you can take up is this one. Now I would say this is very practical example because this is written by someone who is like me, very sweet toothed person, and I definitely would want that bigger piece of cake in any party. So let's try understand how you can find out the maximum length or maximum area of the cake, and you can, so that you can figure out how which piece of cake should be picked up. Now if you see clearly, if you just forget about the vertical cuts, and if you see on the horizontal cuts, the maximum height of the cake piece that will be having maximum area would always have the maximum height, and by maximum height means the maximum difference between the cuts, two consecutive cuts. So if I sort this array somehow in ascending order and then find out the difference between all the consecutive elements, that should give me the maximum height that can be picked up. So that is one part of the problem. Now if I do the same for the vertical cuts, if I sort this again in ascending order, then I would get the maximum width of the cake. Now I know that this is the maximum width that can be there, so that definitely the cake would be picked up from this area. I'll highlight this area with orange, let's say. So the cake would definitely be picked up from this area, definitely. And on the horizontal side, if you take up, let's say, a piece of cake from this horizontal maximum height, so this common area that comes up is the maximum area that you can pick up. So that's the largest piece of cake that you can pick up from this. So so the solution to this problem is very simple, very clean, that it states that you just have to sort these two arrays in ascending orders, and then try to find out the difference between each and every cut respectively. Now the maximum difference would be the one of height or the width, and then you can just multiply and do the modulo with 10 to the power 9 plus 7, and that's the answer. So let's see how we can do it. So I'm just writing the horizontal array over here, and let's see how would it look like when it is sorted. So when it is sorted, it would be something like this. So this is the horizontal array. So for the horizontal array, if you start by the first cut, so the first cut is the first height that is possible for you. So that is always the first element. So first height is this one. So that means the first possible height of your cake would be 1. Then the second would be 1 again. Then third would be 2, and then fourth height, definitely there is a fourth height, because if you see there is a remainder cake over here, so that would be again that would be 1 unit. So maximum unit is 2. Similarly, with vertical, I have also found that uh, this is the sorted array 1 comma 3, and if I find the difference, the first is 1 unit, the second one is 2 unit, and then again 1 unit. So if I try to find maximum from all these three elements, I know that 2 is my maximum, and if I find maximum from these four elements, then I know definitely 2 is my maximum. So my answer would be max of height into max of width modulo 10 to the power 9 plus 7. So this would be my answer. So this is the approach that you would take. Now let's write a pseudocode for this, and a pseudocode or the algorithm in plain English, and then we'll have a look at the actual code in Golang. And definitely you can have that code written in any language that you wish if you know the logic. So I'll be explaining the logic first of the code. We'll be writing the algorithm one by one. We'll break down the algorithm one by one, and then in the last few seconds or few duration, a very small duration, I'll explain the actual code written in Golang. That is my favorite language, so I write it in Go. But you can choose any language that you want, and you can just convert the algorithm that I explain in any language of your choice. So guys, if you are liking the description or the discussion on this video right now helpful for you guys, so please do not forget to like, share and subscribe to our YouTube channel, so that we get any feedback from you guys, and it keeps us motivated to create new content and help you guys with new videos on any topic that you guys wish on. Also, please do comment down below on any question of LeetCode that you want us to solve in our next video. We would highly appreciate that, and we would try to do that in next video. Now let's jump to the algorithm here. So now let's understand the algorithm that is final, and then we'll do a basic dry run with another example, and then finally look at the code. So the algorithm states that in the first step, sort both these two arrays in ascending orders. So by both these two arrays, I mean the vertical and the horizontal cut array. Now we would add the height in the horizontal array and the width in the vertical array. Now why do we want to add this height and width? If you remember, we had to find the last value, so the final cut. If you remember, we tried to find this last cut because we had only three values mentioned in the horizontal cut, so we actually had four different rows. So that's why the fourth, to find the fourth difference as well, because that can definitely be maximum in certain cases. So that's why we add the fourth value, or the height and the width in these two arrays after sorting the array. Okay, hope this is pretty clear to you guys. Now, after adding these two values, I'll start iterating on these two arrays independently. So first we'll iterate on the horizontal or the vertical, and then we'll again iterate on the second one. And then we'll try to find out the max difference in all the elements now. So once you have the max difference in the step 4, we'll just multiply the max difference from both these arrays. And the multiplication would be then had a modulo with 10 to the power 9 plus 7. That's it. So that's a very simple algorithm that you have to do. Now let's try run this algorithm with one example maybe, and then understand if this algorithm stands correct for another example as well or not. Now again, now we have this example, that is second example, and where we have again a piece of cake that has height of 5 and width of 4, and the horizontal cuts, we only have two horizontal cut, that is at first and the third unit, and we have just one vertical cut, that is on the first unit. So now if you notice, there are two piece of cakes that have both have same area. So it doesn't matter, you just have to return the maximum area of piece of cake. So that's definitely 6, right? So I don't care about first or second or any sequence, so I can return one value definitely. So wherever I find the first value, I'll definitely return that. So let's try and understand and solve this with the algorithm that we just decoded. So let's go to the algorithm. So the algorithm that we have written over here is, first we'll sort these two arrays, and in second step we'll add the height and width of the cake in the horizontal or and the vertical arrays. Now let's do the first and second step in this question. So if I sort my horizontal array, so this would become 1 comma 3, and if I sort my vertical cuts, then this will be 1 only, because there is no other element definitely. Now in the second step, so step 1, so this is my step 1. Now I go to step 2. After step 2, what would happen to my array? In horizontal cuts, I would add the height of the cake, and in the vertical cuts, I would add the width of the cake. So over here, 1 comma 3 comma 5, then this would become 1 comma 4. So this is my new array. Now with this new array, I start finding the difference, because that's my third step. If you remember, the third step states that find the maximum difference in all the element in both the array. So now I'll create two variables. One is max width, and then max height. Okay, now for third step, step 3. So for vertical, let's say horizontal, my differences would be 1, then 2, and then 2 again. And for vertical, my differences would be 1 comma 3. So those are the two differences. Now if I find maximum from here, it is definitely 2, and if I find the maximum from here, that is definitely 3. And in step 4, if I multiply 2 into 3 and then modulo it by 10 to the power 9 plus 7, So this is 6 and modulo by a large number, that will not have any impact. So that is why my answer becomes 6. So that means the algorithm that we have written is helping us in this scenario also. Now what would be your time complexity? Now the time complexity would be for this array, when we are sorting this in the first step. So in the first step we'll have n log n. Now n states the length of the horizontal cuts, and for the vertical one, let's say the length is m elements, so m log m. So this is the best case scenario of sorting. So in sorting, if you know that the best possible time complexity is big O of n log n. Okay, so this is my time complexity for this. And then for finding the maximum, I definitely need n iterations and m iterations. So only one time we would have to iterate in the complete array. So that means my total time complexity, if I mention over here, my total time complexity can be uh, sorry, n log n plus n, because we need to find the maximum for the horizontal, plus m log m plus m. So this is my total time complexity. Now if you know, in time complexity we would remove the lower order terms. So from n log n and n, so from these two, this is the higher order term and this is the lower order term, so we definitely would remove plus n from here, and similarly from the vertical array as well. Now this is my time complexity, which is n log n plus m log m. Now again, the final time complexity would be maximum of either these two. So my time complexity of my code is big O n log n. So this is my time complexity, and space complexity is again uh, O of n, because the sorting algorithm, the space complexity can be n, so it may create another array internally and then sort it. So that's why the space complexity, best case, we would take the upper limit, and we have this either O n, a big O n, or if you use some other algorithm, then it can be O of 1 if it is in place sort, but I would not take that, because we are discussing about the worst case. So I am pretty sure that the sorting algorithm that you would be using for best time complexity have a space complexity of O(n). So this is my algorithm, and you know the time complexity and the space complexity for the algorithm. Now let's see the piece of code written in Golang. But if you know the logic, you can apply this in Java, C Sharp, C++, C, any language that you want to apply it in. So now this is the code that I've written in Golang, and this is pretty generic code and can be uh, copied and can be used in other languages just by replacing the syntaxes of the corresponding language. So in Golang, I have used the sort library to sort my two arrays. If you remember from the first step, so I have sorted the horizontal cut and the vertical cut. This is my step one. Now I have added the horizontal height and the width of the cake, step 2. This is my step 2. I have declared some variables, max height, max width. N is the number of elements in the horizontal cuts, m is the number of element in the vertical cut, and this I have calculated after adding these two values, height and the width, so that I have the fresh value. Now I have run a loop that is for the horizontal cut, and I'm trying to find the maximum height. So for iterating from 1 to n, so my maximum height initialized is with the zeroth. value. So zeroth is the first difference that for the horizontal and for the vertical cut as well. So the initially vertical and horizontal heights maximum of these two would be the first value of the array. Now I've started my iteration from the second element, that is I equal to 2 index, and started finding the difference of this current index and the previous index. So that's the difference of height or the width that I have, and I've tried to find the maximum value from this difference and the previous maximum, and this has been stored. So for the complete iteration, I'll have the maximum value stored in the max height and the max width. So these are the max values, and then I multiply them and I do the modulus. So this is the code. So this part, finding the maximum, is step 3, and this is pretty much step 4. And now if you know, this is time complexity O n log n. So this is the time complexity for these two sort cumulative together, because the maximum of these two, so n log n or m log m, so maximum of these two. And then again time complexity for step 3 would be n, maximum of either two. So n here represent maximum of n or m, over here also maximum of n and m. Okay, so the final time complexity becomes final time complexity, if you see, it is n log n. So this is my big O of n log n, and space complexity becomes big O of n. So that's the code in Golang, and hope you find the explanation pretty easy and helpful for you, and let's see you in next video. So that's it for this video today, and in case you liked the video and it was helpful for you, please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want any particular question from LeetCode or Geeks for Geeks to be solved by us on Golang, or any other topics that you want us to cover for you guys using Golang. So go ahead and comment down below as much as you want, any topic on Golang, using Golang. We appreciate you guys to do that.